Un- Unveiling arch secrets, testing masonry under horizontal truss. Analysis, analysis or testing of arches under horizontal truss, a crucial concept in architectural conservation, structural engineering, and masonry research. And there are some breakdown which must study involved where, where we are looking at it historically. The significance of horizontal thrust are arches work primi- primarily in compression, but they exert outward horizontal thrust at the supports. This thrust must be countered to avoid structural failure. In historical buildings, it's often resisted by buttress, tie rods, or adjacent structural mass. Understanding how different masonry types and joint conditions respond to this stress reveals their load-bearing secrets. Preserving preserving heritage. Arches are, arches are central to architectural heritage. Worldwide example, Roman aqueducts, Gothic cathedrals, Mughal gateways. They represent the cultural, aesthetic, and engineering achievements, often composed of unreinforced masonry, highly dependent on compression and geometry. Modern challenges: structural instability, horizontal trust leads to spreading at supports over centuries. The support materials may weaken or shift. Temporary fixes like tie rods or concrete injections may compromise authenticity. The third one, informed restoration. Inform Evidence based methods like limit analysis, finite element modeling, and line of thrust, the use of non destructive testing like laser scanning, digital photogrammetry, thermo- thermography, the monitoring systems for long term thrust and moving tracking. Okay. And accurate testing informs better repair and reinforcement, and ensuring these marvels stand for centuries more. The water segment masonry arches. These arches feature a curved shape that is a segment of a circle often used in bridges and historic buildings. They rely on the compression of individual stone or brick units to bear loads. A segmental arch is a type of arch where the arc is a segment of a circle, typically less than a half circle. Unlike semicircular or pointed arches, segmental arches have a flatter profile. The key factors are like span, shape, thrust, and angle, common angle range. And applications like segmental arches are widely used in bridge construction, door and door and window openings in traditional buildings. Understanding horizontal thrust. Understanding horizontal thrust is essential to grasping how arches and walls work, especially in masonry construction where materials are weak in tension but strong in compression. The horizontal thrust is a sideways force exerted by an arc or on its supports as it carries vertical loads like weight people or environmental forces. It occurs it Why it occurs? Because arches convert vertical loads into compressive forces along their curved path. Because the curve isn't vertical, some of that pushes uh, outward. This is the horizontal thrust. Visualizing it, visualizing, visualizing it. Imagine seizing a boat stick from the top. tries to flatten and spread outward. That's what an arc, arc does to its support. Hoti thrust. A study especially attaches Hoti thrust, horizontal thrust eh, exerted into the arc, often from external factors like soil pressure or uneven settlement. In geological terms, it's possible you are referring to a thrust fault or geological formation called Otitus, like in tectonics or mountain building zones in regions like the Himalayas or the Balkans. The thrust are common geological terms used to describe layers of rock pushed over there. Others. Potential for collapse in masonry arches, especially under horizontal thrust, is a key concern in both historical preservation and structural analysis. Here's a focused breakdown: what increases that risk, how it assessed, and what can be done to prevent it. The potential collapse, the potential for collapse in a masonry arch arises when the internal forces horizontal thrust exceeded what the supports and materials can resist, especially if the line of thrust exists the arch body. Through structural analysis, careful restoration, and non-invasive reinforcement, collapse risk can be significantly reduced. Replicating reality. Designing an experimental setup that replicates real world conditions for testing masonry arches, especially under horizontal truss, requires careful balance between scalability, realism, and control. Below is a guide to creating such a setup suitable for academic research, heritage analysis, or engineering validation. The goals of the experiment is to replicate horizontal thrust behavior in real arches, observe failure modes, measure load paths, displacement and stress distribution, test effects of material degradation, support movement or reinforcement. A well-designed experimental setup for masonry arches must combine accurate geometric modeling, representative materials control, loading, and detailed measurement tools. The more closely you simulate real-world degradation and support conditions, the more valid your conclusions for conservation and engineering. Applying live load. Live loads represent temporary moving or changeable loads acting on a structure like people, vehicles, or furniture in real life. In an experimental setup for testing masonry arches, applying a realistic live load is crucial to simulate how to arch behaves under real world dynamic conditions. Objective to simulate the live load effects on a masonry arch and observe how it influences horizontal thrust, deformation, and failure mechanisms under realistic service conditions. Applying live load in arch testing through point distributor or dynamic methods helps us simulate real world service conditions. It's vital for understanding how the arch system responds to use, movement, and stress redistribution, especially in the heritage structures. Introducing Fortitas. It appears there's very limited direct information available on a geological figure name the Hoti Trust, suggesting that it may not be widely recognized or well documented trust fault under the specific name. It's possible it refers to a local or informal trust structure in the border and fold trust belts of northern Pakistan. If Hoti Trust is a minor local trust in NW Pakistan, likely the part of the full trust belt network around cohort or Podwar plateau, structurally similar to Kahit trust or other four and back trust in that region. A mislabeling or lesser known feature could refer to a small place small place of the MBT, HFT or fault drain trust systems which are well studied in the regional tectonic literature. Unexpected arch behavior. Contrary to contrary to some traditional assumptions or tests reveal that certain segments arches exhibit significant sig- out of plan deformation before full collapse even under primarily in plain loading. This means their failure isn't always a simple 2D mechanism requiring a rethink of analytical models. Pinpointing a failure mechanism. We observe distant hind formation patterns under combined vertical and horizontal thrust. These plastic hinges dictate the ultimate load carrying capacity. Understanding this specific failure points is crucial for predicting arch strength and designing effective strengthening interventions. Absolutely, these three themes from the foundation for any responsible and forward-thinking approach to historic masonry structures, especially those involving arches and walls. A safer design, E- even in heritage context, design decisions must prioritize prioritize structural stability and long-term resilience without compromising historical authenticity. A principle like understanding structural behavior, horizontal trust, use scientific methods, design minimally invasive reinforcements, prepare for hazards. Example like designing a steel tie system for a stretch heritage church arch that prevents spreading spreading what is reversible and hidden. Better restoration is not just a repair, it's about understanding the original intent, materials and geometry, then intervening sympathetically and reversibly. Best practices like material compactability, reversible techniques, preserve original geometry, use non-destructive methods, and the third one, preserving history. Every stone, crack, or keystone tell a story. The preservation should aim to retain authenticity, document interventions, and educate future generations. Actions that preserve life, comprehensive documentation, respect patina and aging, interpret history, community, and environment. UK's built past. In medieval period up to 1500s, stone castles and cathedrals, example Tower of London, York Minster, the use of local store and timber framing. Second one, Tudor and Elizabethan, 1500s to 1600s, timber framed buildings with wattle and daub infill. Early use of brick in wealthier houses. Third one, Victorian period, 1800s. Industrial revolution surpasses mass production of brick, iron, glass, Gothic revival architecture. Fifth one, the traditional masonry, load-bearing walls of bricks or stone, arches used in bridges, doorways, walls, lime mortar, are commonly used. Conservation of UK's built heritage is to protected buildings, listed buildings like grades 1, 2, 3, heritage bodies, historic England National Trust. Techniques focus on repairing rather than replacing. Importance of traditional materials and craftsmanship. Thank you.